Hello and welcome to Partially Redacted, a podcast where we discuss privacy and security engineering and related topics. I'm your host, Sean Falker, and today I'm joined by Piper Keyes, engineering lead at Skyflow, and we'll be talking about building privacy-preserving data pipelines. Piper, welcome to the show.
Thank you so much. It's great to be here.
Yes, thanks for being here. Why don't we start by having you introduce yourself? Who are you? What's your educational background, work history? How did you end up where you are today?
Yeah, so as you said, I'm Piper. I had a somewhat non-traditional path to becoming a software engineer. All of my educational background is actually in neuroscience, or like biopsychology, but basically neuroscience. And I did my PhD in neuroscience in the Bay Area at Stanford. And pretty quickly realized that that was not the career I wanted to pursue. I spent probably about 90% of my time collecting data and 10% of my time actually thinking about the data, designing experiments, doing the critical thinking that I actually enjoy. And so while I was there, a bunch of people recommended to me, hey, you should check out CS. You might really like it. And so I did that and took a bunch of the core CS classes, I guess, that's part of the degree at Stanford, and a couple upper level classes, and kind of decided this scratches the same itch as what I liked about, thinking about neuroscience, which is problem solving, designing. In, neuroscience, it was experiments, but in CS, it's designing architecture and systems. So after I finished my PhD, which I mostly did because I could take these classes for free and kind of prepare myself to transition over. I joined a startup that it was called Open Lattice. It I think got bought at some point, but I worked there as an intern and then as a software engineer for maybe a year, and then came to work at Skyflow. Originally because I really wanted to learn the tech stack that we use here, Docker, Go, Kubernetes. Those were all technologies that I thought were valuable skill sets to have. And at the time, I didn't really think that much about the product. I wanted to learn the technologies. But as I have been here longer, it's become more and more clear how essential the platform we are providing is in this day and age, both for the betterment of people as well as the need for it based on kind of all of the legislation around data privacy. So that's kind of how I ended up here. And then I've been at Skyflow for almost 3 years now. So hard switch from biological sciences into computer sciences for me.
How many people were at Skyflow when you joined? 3 years? This company's only was formed in 2019, so.
Yeah, I think it was less than 20 at the time. It was primarily engineers, and Anshu was obviously here. We had a CTO at the time, and a couple other administrative roles, and then maybe 10 engineers. It was very small. I think they were about to get Series A or had just gotten Series A.
And then what was the original goal with doing a PhD in neuroscience? Were you hoping for a career in research or to become a professor or something right now?
Yeah, I think that was kind of the thought when I was a bachelor's student, just taking the neuroscience classes and working in a lab. And I still love thinking about neuroscience. It's my favorite thing to think about. But basically what I found was that the job of doing neuroscience research was very different from taking classes in neuroscience, where you just spend a lot more time moving mice around and creating solutions and stuff than actually thinking. So I initially thought I'll go be a professor, and then kind of realized I wasn't really enjoying my day-to-day,
Yeah, I kind of went through a similar realization as well, where I was doing essentially a postdoc in same department as you, but in bioinformatics at Stanford, and
Yeah.
I realized like I don't know that this is the type of work that I was doing was ultimately what I really wanted to do, because the amount of work that I was doing that I really enjoyed was only that 10 to 15%, and I actually
Yeah.
like kind of building stuff that people would actually use much more. So
Yeah.
that's kind of where I made that pivot. But were there, skills essentially that you learned as like a researcher in, biology and neuroscience that are transferable to what you do now, or sort of
Yeah.
skills that you developed as an engineer?
Yeah, absolutely. Because what I always like say to people who ask like what's it like to get a PhD is it's largely like a boot camp in critical thinking and like pattern identification. Because basically like when you're doing an experiment, you've like designed this set of experiments that you're trying to prove some like overarching point. And when you start collecting the data, maybe the results are not what you expected. And so you have to think what different components, like of, let's say you're studying the brain, like components of this subsection of the brain could be leading to this result as opposed to what I thought I was going to find. And that's basically debugging. You have to understand the components to understand the behavior. And especially with neuroscience, I think studying the brain requires like thinking and switching quickly between thinking about like very high level concepts like systems, like this brain region is going to talk to this brain region, which is going to split its signal into like these downstream brain regions. But also you need to understand like the cell types in that brain region and what each of those individually does. And that is very similar to software, where you need to be able to very quickly flip between here's the architecture and like the large scale of the feature or like the product I'm working on. And then, but immediately I'm writing this code. And so I need to understand what this piece does and how it will affect like the larger whole. So I actually think it's extremely translatable. As, like if you're going to pick a PhD that's not CS and end up a software engineer, neuroscience works pretty well.
Oh yeah, it's like the unconventional path.
Yeah.
They just do 10 years of school in neuroscience, and then take
Right.
a couple years there.
Yeah, it's
Awesome.
definitely not the most efficient path.
Yeah, well, slightly more expensive path.
Yes.
So we're going to be, we're just kind of, pivoting a little bit into the topic at hand today. We're talking about, data analytics pipelines, particularly, essentially privacy preserving data analytics pipelines. But maybe before we get to that, starting just at the very basics, what is a data analytics pipeline?
Yeah, so I think that's a really big question, and I'll give kind of a high-level answer of like my perspective on it. So I think it's generally a workflow that starts by extracting data from, it could be one source, could be many sources, and it's going to take that data in, transform it, process it, perform analytics, whatever your specific use case is, and then potentially export that data to, again, one or many sources. So it can be, a one-to-one transformation. It could be a many-to-one, one-to-many, many-to-many. There's a lot of flexibility on like the I/O of the pipeline, but I think the primary feature is that data is going to be pulled in, transformed, and insights are going to be drawn from that data.
And then what are the kind of like tools that typically get used by, companies that are building these types of pipelines?
Yeah, I mean, I think it depends on the specific use case. Because there's like we have a streaming use case where data is going to be coming regularly, like maybe through like a Kafka queue or something. I'm less familiar with those tools, but in the case of like batch processing, at least from my experience, you need some kind of like orchestration tool, which we've landed on Airflow as that. But you could use something like really depends on the use cases. But we also looked into like Argo CD is like a container orchestration tool. But you need some kind of orchestrator that will allow you to maintain like atomicity, which is basically performing like one step to completion before moving on to the next step. And then item potency, which is basically ensuring that the outcome is the same every time from that step. So some kind of orchestration framework or tool that allows you to be confident that you're maintaining those two features of your pipeline. And then, I think a lot of people, again, depends on the use case. A lot of people use Python for data analytics because it's very good with like handling matrices, especially if you're using ML. Python has a lot of good tools for that. But yeah, it depends on the use case, I guess is the true answer. Yeah.
Right. Yeah. And the modern data stack also consists of, there's just like so many tools in the tool chain now that, do a variety of different things that, like, if you need an orchestration tool, there's probably, at least
dozens,
10, 20 of those that you could make your choice from. And then, going a step further, what does it mean to like actually build like a privacy preserving data pipeline?
Yeah. So that, I think, it includes a lot of the same like features of a normal data pipeline, but I think that the key is that keeping the sensitive data that needs to remain protected, keeping that like feature of the pipeline at like the forefront of every design decision you make is absolutely essential, because once you start processing data, it moves a lot of different places. It may be coming in from multiple sources, maybe getting sent to third-party sources or vendors to do some sort of validation. Like maybe you're processing credit card data and you only want to look at credit cards that are currently valid or active. Maybe you send that up to some credit card validator service and then down the line, like send it to one or many like data syncs. If you do not feel confident that you are protecting the sensitive data, like the CDDs and whatnot that fall under PCI, it will be nearly impossible to track all that stuff down once it's gone through the pipeline. So I think the primary thing is you have to build the pipeline with privacy preservation in every single design choice you make.
So that makes a lot of sense. Like if you're, especially like in the example you're talking about, where if you're dealing with like credit card information, clearly you don't want that ending up in the clear somewhere. And if you do that, you'll be violating PCI DSS, plus potentially compromising your customers' information and so on. But what are sort of the techniques or strategies an organization would use from an engineering perspective to make sure that kind of thing doesn't actually happen, like it doesn't end up in a log file somewhere or something like that?
Oh yeah, log files. Part of it is being a thoughtful engineer, I think, and thinking about what you're logging. But I would say, I would argue that managing that sensitive data as far like forward in the process, that is a good pattern to follow. So before you start doing any sort of like analysis on the data, you should use some mechanism of obfuscating the sensitive data before sending it further down the pipeline. That I would say is probably the most important thing. From like when you're designing like the steps of your pipeline, like step 1, make sure that we're not sending anybody's data where it's not supposed to go in plain text. And yeah, I mean, like the tools that are available, like I know that there are some ML-based de-identification tools. Those, like I've never used them. My main, I guess the thing that like sticks in the back of my head, because we've talked about using those, is that like sort of by definition, like deep learning algorithms cannot be 100% accurate. It's if your algorithm or like your neural net is working at 100% accuracy on your training data, it's probably overfit. At least that is what I learned in like the class that I took. So I think that's like a good auxiliary tool, like that can be part of the pipeline, but it's also important to like design your data, like your data warehouse well to begin with, so you know where the sensitive data lives.
Right.
Yeah, I don't know if that really answers your question or if I went on a tangent, but
Yeah, well, so I mean, I think you make a very good point about sort of knowing where the data lives, because I think one of the big challenges, of course, any company can run into, when, especially when they're handling sensitive data in one of these like big analytics pipelines, is that it simply can end up in a lot of different places, and you lose track over time of like what and where you're storing that information, and if you don't know what you're storing and where it is,
Yeah,
it's pretty hard to know that it's secure or whether you're in violation of some sort of compliance regulation.
right.
You mentioned a couple things though in there around like obfuscation and de-identification. So what does that what does it mean essentially to de-identify data, and how does that work?
Yeah, so de-identification, I think it can be done a number of different ways, but it basically means that, if somebody were looking at the plain text data, they would not be able to use that to actually identify a person. And there's a lot of strategies you can use. I think common ones are, you can redact that data, you can mask it. So only, like with a social security number, you only see like the last 4 digits or something like that. Or you could tokenize it. And I think that tokenization is particularly useful because if you ever need to re-identify the data later, you have essentially like a key that you can send to whoever maintains that token to get the actual value back. And maybe your like business case can't actually look at that, but maybe you're interacting with some, PCI compliant third party that needs that information to perform whatever, task you need them to perform. So yeah, I think redaction, masking, tokenization are kind of the big common like ways to de-identify or obfuscate sensitive data.
Right. And you mentioned that the idea of re-identifying the person. So, if we take a specific example going back to this like, credit card scenario, maybe we're doing some sort of machine learning on transactional data, but we
Yeah,
want to be able to send some portion of it on to, I don't know, some third-party service that's going to be able to detect whether, I don't know, fraud is happening on that person. Then we might want to re-identify that user in order to
right,
tell them that something's happening to them, but not necessarily expose our systems to who that user is. So something like
right.
tokenization would allow you to facilitate something like that. Is that right?
Yeah, absolutely.
And so we've been talking a lot about this, made up scenario of the credit card transaction. But are there
Right.
what are some other examples of like use cases where if this idea that engineers need to be really thoughtful about the handling of that data and be thinking about privacy, have privacy essentially in mind from the get-go when it
Yeah.
comes to building these types of data pipelines?
Yeah, so there's one thing like there's one use case that I've thought of a lot recently, which is essentially like ML-based pipelines for advertisements in like apps like Instagram and things like that. Um and what scares me is kind of what I mentioned before about ML is like it is by definition like black boxy. So you don't really know how that neural net or whatever it is came to make the decisions it's making. And if you're not like confident that the data that you're feeding into this pipeline are accurately de-identified, it's going to be very hard to understand where that information went, Um so that's just something I've been thinking about a lot is, like big companies, I don't know if it's faux pas to like use names, but it's like, Facebook there was an article that I saw, I think it was like posted in our Slack like read stuff channel, that there was an engineer from Facebook who said there is literally no way that we can track down all the sensitive data that we have. There's no path to follow. And I think a lot of the reason they collect all this data is to sell ads, because that's a big, revenue generator. Those are the things that really scare me is like creating essentially like an ID of a person to like sell them more stuff, and like selling that ID to other companies that are going to advertise to them. It very quickly, your personal information can get spread. It's like, opening a floodgate basically. So yeah, that's a specific use case where I think that ahead of time, and sure, I mean, it may be too late for some databases, I don't know, but ahead of time, if you're building something new, ahead of time, making sure that if you're going to be sharing this information with other companies, with other, like you're going to be passing it to somebody else's data warehouse, it's out of your hands at that point. So you have to be very intentional about ensuring that nothing gets sent down the line that you can't get back, you know?
Mm-hmm. Yeah. The former head of security at Twitter had come out last year and said a similar thing about Twitter, essentially that they essentially have no idea where the user data is. And I think, Facebook and Twitter get a lot of like heat for these types of things, but the reality is tons and tons of companies have this problem. Like they're kind of like easy targets for this, but tons of companies I think that have developed over the last 20 years when we weren't really asking ourselves about, why are we collecting this information? What are we actually doing? We were just like building these like huge systems that are like scaled globally. We weren't worrying about the backups of our database having PII in them or like the log files. We log an exception and it has some user information in it. We weren't really thinking about those things at that level. And now it's really hard to retroactively, fix those problems, I think.
Right. Yeah. I don't know if this is inappropriate to say on this podcast, but it falls under the like fuck around and find out, where like when big data became a thing, everybody was just collecting as much as they could. And now we're finding out that like there are a lot of dangerous implications based on that kind of, I don't know if reckless is the right word, but like not very thoughtful behavior. And yeah, I think it's all over the place. Like probably almost any company that collects some kind of user data has leaked some of it somewhere it shouldn't have gone. So yeah, on the same page about that for sure.
Yeah. So in the case though, where a company essentially is, thinking about this from the get-go and they're taking the proper steps to de-identify data, like maybe they're using some sort of, tokenization process and they're using other, ways of essentially controlling who can see that data, what data they're storing, what they're passing downstream. How does analytics work in that scenario? Because, presumably these companies originally were storing this data in their data warehouse so that they can run sort of these analytical workloads directly against the actual data. But in the case where we're taking the right steps to make it privacy preserving, how do we actually run analytics over essentially the de-identified data in that case?
Yeah, I mean, I think that if you have designed it well, it should work exactly the same because, ostensibly, I suppose, the analytics you're trying to draw are like large scale patterns and not about specific people. And so I think especially if you are using like format preserving tokens, the data you're running your analysis on to any like human looks like real data. So you're not even sacrificing like the data format. Like maybe that's important to your analytics. It very well might be. You'll just have like a fake, SSN instead of somebody's actual SSN. So as long as your analytics is not trying to, glean anything about any particular piece of information, which I can't really think, maybe there are examples, but I can't think of one where like that's the outcome you're looking for. Generally, you're looking for like patterns emerging from like a large set of data. So it should work exactly the same from my perspective, I guess.
Yeah, I mean, I guess if you're looking for things like you're trying to aggregate people by geographic information like city, state, country, technically you don't really need to know like have the actual city name in there versus some sort of like random string or something like that. As long as the input of like San Francisco generates the same random string every time, it's essentially de-identified. But from an analytics or machine learning perspective, like the machine doesn't care that it's ABC 123 versus San Francisco written out.
Yeah, absolutely.
And then you mentioned this idea of like format preserving. So I take it in that case, what's happening is you could take something like a phone number and you're producing something that still looks like a phone number, but it's not an actual original phone number. Is that right?
Exactly.
What are, some of the big challenges in, building a pipeline like this that does work to essentially preserve privacy. Hey there, it's Sean, host of Partially Redacted. You probably guessed that, since at this point in the interview, you probably recognize my voice. I've been told for years that I have a face for podcasting, but no one has mentioned whether I have a voice for podcasting, so sorry about that. Hopefully, the awesome guest makes up for it. Anyway, if you're enjoying this episode, please support the show by subscribing and telling your friends. You can also join Partially Redacted community at skyflow.com/community. Okay, that's enough for me. Back to the show.
Yeah, so I think that what we have found, because we've been building one, is when you're trying to build something this big and complex, it's very easy to get kind of tunnel vision on like the use cases you're currently addressing. And to some extent you have to, right? Because you have to address those use cases, but building flexibility into that pipeline, I think, is extremely important. Which is why, I mentioned earlier that our strategy is basically like an orchestration framework that spins up a Kubernetes pod that does some, like, maybe not bite size, but containerized piece of work that is independent of the other ones. And that allows us for the flexibility of essentially changing the graph. So maybe in some cases we need an extra step. Like maybe we need to do some like data decryption or encryption in some cases and not in others. That's a level of flexibility we want to support because the different people using the pipeline may have different requirements. That, and then I think that one of the hardest things that we have come across, maybe not hard, but just time consuming, is that the security that we are striving for starts at like the architecture level and goes all the way down to the code. And designing secure architecture is just inherently more complex than just designing some architecture that works. We have to think a lot about where are the data that we are touching, where are they actually being processed, like where are they being read into memory? Is that a secure environment? So it's just, there's a lot more thought and a lot more effort that has to be made, I think, from our infrastructure team has been very busy helping us because there's a lot of work on their side. But high level is that if you're adding the complexity of security into your designs, you need to be much more careful. You need to think things through from multiple different angles. And I think it just takes longer.
Yeah, and I think it's one of the things you mentioned at the beginning there was this idea that of flexibility, and I think it's probably one of the big challenges that a company that is trying to develop this completely on their own is going to run into, where maybe they can come up with a bespoke solution for their particular like use case today, but is that going to sort of be too brittle and too inflexible a year from now when they encounter like another use case? Versus if you do go with some sort of vendor solution, then the vendor's probably seen like, hundreds of different use cases. So they're going to have something that's like more flexible, and essentially that their job is to be thinking about this particular problem.
Yep, exactly.
So going back to, one of the use cases we kind of like talked about at the very beginning, this idea of like having like customer transactional data, like let's say it's like credit card data from Visa. Mm-hmm. So like using the example of like Skyflow's like pipeline support, starting to focus a little bit more on how Skyflow does this. How can you walk me through essentially like how does someone ingest data from say like Visa's transactional data into the warehouse without having to essentially build a bunch of PCI compliant infrastructure?
Yeah, so I think that why we are building this tool is because I think a lot of people have a use case that's exactly that or very similar to that. And so our privacy data vault is a really like convenient backend to use for de-identification of data while still like maintaining the usability of that data. So let's say you have your data that's coming from Visa. Maybe they pushed it to some, I don't know, like S3 bucket or like SFTP server or like some sort of like data warehouse. Our like the pipeline we are building can pull that data in for you. And if you provide us essentially like based on the data that we're pulling in for each like source field in that data, where do you want it to go in your vault? We can pull all of it in, write it into your vault, tokenize, like let's say you want that, you need that data to go somewhere else, like into your own backend. We can take that data, write it into the vault, generate tokens for every data point, replace the sensitive data with those tokens, and then send that along to your warehouse. So then your pipeline can begin from your warehouse. And if you ever need to, let's say, like re-identify the data and send it back to Visa or to, whomever for whatever reason, you can just, detokenize through our detokenization API. And yeah, you have the data you need right there.
Okay, so just to kind of walk through that explanation. So essentially what's happening is, in this case, like Skyflow is sitting at the head of, like basically before a company's pipeline even starts, they're sitting at the head of that, taking in this sensitive data in a secure way, and then within the vault environment, the secure environment of the vault, de-identifying any of the information that needs to be de-identified and producing essentially like a clean version of the data on the other end. And then essentially the company's ETL pipeline or whatever it's going to be can operate as usual without being worried about any sort of data security, data privacy issues.
Yeah, exactly. Yeah. And I think that makes it easier for the customer too, because then they don't have to think about it at all. They don't have to worry about their own like PCI compliance. They can push that off to us and we can worry about it for them. And their operations don't really have to change at all. The pipelines that they are running for their own use cases can operate exactly the same. We've just done the step ahead of time to get rid of any sensitive data for them.
Mm-hmm. And once the data is in the warehouse, so now we have like de-identified data in the warehouse, and let's say this is like clinical trial data or something like that, and then we need to inform a clinical trial participant about some sort of issue, but we also want to maintain privacy in our systems. You alluded to the fact that we would be able to get back to essentially the original participant. Can you kind of walk through like how would that operation perform or work?
Yeah, so there's a number of ways that it could work, and it kind of depends again on the use case. But so the one thing you could do is Skyflow also has a concept of connections, right? So maybe you can hook up wherever you need to send that data. Like let's say there's some API you have to hit that will eventually send an email to whomever it is that needs information. You can set up a connection to that endpoint and provide the tokens, and the connections feature will essentially take those tokens, replace them with the actual data, and then send that request onto the API. That's one thing that you could do. You could also, I think with our functions, like if there wasn't like an out of the box connection and you didn't want to make one, you could also use our functions feature to do something very similar, where you have the tokens, you provide those, and the function will go and detokenize and then send the email maybe directly. Maybe you want to directly send an email instead of using some third-party email service. Yeah, so I think those are two ways you could do it.
Yeah, so it sounds like there's a lot of options, but essentially the like takeaway is that the business is always going to be essentially doing work against these de-identified forms of the data. So they are protected, but it's by leveraging the vault as a secure environment, the vault kind of knows how to get back to the original values, perform whatever operation you need to do, but without exposing your system to that.
Yeah. Basically, you can always just use the fake data essentially to perform whatever operations you need to perform. The vault will make sure that when the real data is needed, we can get it.
Mm-hmm. So we talked a little bit about transactional data from Visa or some other credit card type of data, clinical trial data. What are there other use cases that something like Skyflow's pipelines product would enable?
Yeah, so we talked about what, credit cards, and what was the other one you said?
Clinical trials.
Clinical trials. Yeah, I mean, like, pretty much, I think that there are probably endless use cases that involve somebody's personal data. Um, like medical, obviously, like the whole field has all sorts of information that gets collected every time you see the doctor, every time you buy or like pick up a prescription from a pharmacy. Like there's so much information that is out there like on a person that should be protected. So if like your use case involves any data that could be described as like HIPAA compliant, under PCI, really anything, you could, let's say you have a bunch of that data now, you are unable to maintain it because you are not compliant for whatever that data type is. The primary reason we made this pipeline was to enable people to move large amounts of data into the vault to, like, they'd be the fastest way to remove your own like liability. I don't know exactly all the laws that are coming out, but I imagine there are some that are basically saying you have this much time until you are considered like out of compliance and will likely get fined. So yeah, if a customer's use case has it touches any like sensitive or like privileged data, I suppose, putting it through our pipeline to get it into the vault and then building your like business logic to just have the extra step of take this token, get the real value from the vault, and then send it on to whoever needs it. Yeah, like any of those, any of those can be.
Yeah, I guess it's a very broad question. I mean, I think generally the idea here is that if you have any customer data that you're storing in your warehouse, your Lake, or whatever your downstream systems are, then you're potentially like putting yourself at risk from either from a compliance standpoint or just even from like a attack vector standpoint, because you're having additional surface areas that someone could potentially attack. And especially when we talk about these like complex ETL pipelines that have a lot of different like components, then each of those components probably have logging systems. Like that data just can get up in a lot of places, like we talked about at the beginning. So by only storing or operating over de-identified data, you're just kind of like de-risking that whole surface area, and you don't really have to worry about it.
Yeah.
And are there, starting to kind of wrap up here beyond just data pipelines and some of the work that you're doing at Skyflow, are there future looking tools and technologies that you're particularly excited about in this space?
Yeah. So I mean, specifically the data pipeline space, or just like in general?
In general, like even data privacy, security space.
Yeah. So I think that something that I'm super interested in, but I'm also like have a healthy I don't know, skepticism, I guess, about it. And I think it ties back into, having spent so much of my life studying neuroscience, the like field of like brain machine interfaces I find very, very interesting, but with the big caveat of, I think that the hype in the tech community about them is a little closer to sci-fi than it is to reality. And I think that like at a very simple level, computers operate on like electrons, right? Like electricity decides the compute of that computer. Decisions are made based on electrons. Quantum computers, I think, make that a little more complicated, but it's still electrons, right? The brain is bioelectrochemical in how it processes information. So that's two additional like vectors of compute, essentially. And I think that, and that's just at like a base level, so I think that a lot of the talk around what I think is closer to like Black Mirror than our reality about like, oh, we're gonna be able to like replay our memories on a computer screen and that kind of stuff. I'm less interested in that, but I think that there was a lab when I was at Stanford. I think it was the Chinoy lab. I don't exactly remember, but I remember seeing a talk from that lab where they had created a brain-machine interface of like a prosthetic arm, and a monkey could use that to like reach towards something. And that is amazing, right? Like the implications of what that could do to help people is incredible. But once it reached, it kind of lost control of the arm, because in like a real arm, there's proprioceptive feedback going back to the brain, and the prosthetic limb could not like emulate that. And that's such a simple task, like reaching for like a dot on a screen. It's so simple, but it is so difficult for a like computer to do, reading input from a human, or in this case it was a monkey, but like a primate brain, right? But that being said, I still think that there is a lot of good research being done in that space, and I think it could potentially be very cool. But it also, I think, is very relevant to data privacy. Anything medical, I think that, not that I'm an expert in that field, but it definitely seems like the medical industry is not as careful with user data as it should be, especially, startups that are trying to move fast and get stuff done. I think that stuff is often thought about second. So as we like move tech further and further into like the medical world, I think that is a very it's great, because I think a lot of innovations come from it, but it's also a little scary. Like a brain machine interface, we don't know what kind of data they're collecting. They could be collecting like signatures of your brainwaves. Who knows if that could be like relevant later, to like identify, I don't know, like mental illness, and then maybe you end up getting discrimination at a job because you have a brain signature of someone with like depression, or I'm not really sure, but yeah. So that's a field that I think is very cool, and I'm very glad that a lot of research is being done into it, but it definitely seems like it has the potential to open up some new fields of data that like we don't even think about as being like personal and private. So long answer to your question, but I have thought about that a lot.
No, I agree. I think it's a super exciting field. Like I think there's a lot of you see there's technologies around like restoring eyesight and also like hearing, and and there's just like barely scratching the surface of what could be done there. But as you mentioned, there's also potentially a lot of scary things from like a data privacy standpoint. I think that's true of a lot of innovation that happens. Like the challenge is innovation and technology a lot of times moves much faster than things like regulations and compliance. Yeah. But I think ideally we're hopefully shifting the world, and especially the world of engineering from an education standpoint, to kind of be thinking about these things and understand that this needs to be a priority from day one, and not necessarily be like an afterthought because you're too focused on essentially delivering whatever the product is, because you should be doing these things because it's the right thing to do ultimately, right, not because some sort of governing body's telling you that you need to be doing it.
Absolutely. Yeah.
Well, awesome. Thanks, Piper, so much for joining and for, sharing your experience, both from, transitioning from neuroscience into computer science to, now a software engineer at Skyflow, and also sharing your, insights around the considerations of building, privacy preserving data analytics pipeline and how that would work essentially with Skyflow.
Yeah. Thank you so much for having me. This was a lot of fun. Actually, I thought it was going to be much more scary than it was.
I'm glad that it wasn't too scary.
Yeah.
All right, thank you.
All right. Thank you so much.